Hello everybody, getting ready to do lesson 2.5 part 2 today of classwork for Algebra 1 Math. And on your classwork sheet you got 8 points. Students, have that out in front of you now. You'll have 6 points going to your notebook or your notebook guide. On your tablet or your phone, students, put your name, date, period here or your paper. And page 1 of today's lesson. And we're going to start off here with example 3. Solve a real-world problem. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? So, okay. So let x represent the number of years from now. So 6x represents the increase in the number of new cars sold over x years, and negative 4x represents the decrease in the number of used cars sold over x years. Write a verbal model. Okay, so let's try this here. New cars sold this year plus increase in new cars sold over X years equals 2 times the quantity used cars sold this year plus decrease in used cars sold over X years. So there's your verbal model. Now our plug-in, new cars sold this year is 78 plus increased new cars sold over X years will be 6x will equal 2 times the quantity 67 plus a negative 4x amount here. So you have a negative amount here and then a positive amount here. So when we put this into a strictly algebraic expression, we have 78 plus 6x equals 2 times the quantity 67 minus 4x. That writes your equation. And so when we multiply through here, distribute our multiplication, we have 134 minus 8x up here equals 78 plus 6x. So now, hopefully, when we solve for x, we can come up with our magic numbers here. So 78 plus 14x equals 134. We added 8x to each side. And then we divide through, or rather, I'm sorry, we subtract 78 from both sides. We've got 14x equals 56. And then we divide through by 14, and we get x equals 4. So the number of new cars sold will be twice the number of used cars sold in 4 years by that expression. So, okay, so what do we do with that? Check. You can use the table to check your answers. So here's our table here from that function. Your 1, 2, 3, 4, and then double new cars sold will be 102 on your 4. And then your used cars sold will be 51. 4 years down the line, you should double your used cars sold by that. I guess you call it an algorithm. So the number of new cars sold is twice the number of used cars sold in 4 years. Let's go into a guided now, students. In example 3, suppose a car dealership sold 50 new cars this year instead of 78. In how many years will the number of new cars sold be twice the number of used cars sold? So I think we have to use the same thing there. And then this is yours down here, students, to take a shot out. In how many years will there be 3 times as many students taking Spanish as French? So you have rates of change here. Basically, you have where a line intersects. That's where your solution would be if you were to graph these 2 different functions. So this is what we did prior. Now we've changed our up there. We've changed it to 50 new cars this year instead of 78. So we have 50 plus 6x equals 2 times the quantity 67 minus 4x. I mean, this is our new algorithm here. So we have 50 plus 6x equals 134 minus 8x. And we have 50 plus 14x equals 134. We have a different number here is what we have. And then when we, we're gonna move our 8x over here. That's how we got 14x here. And then this needs to be moved. So we're gonna subtract 50 from both sides. And we get 14x equals 84. Divide through by 14, we get x equals 6. So we get it after 6 years from that number. The number of new cars sold will be twice the number of used cars sold in 6 years is when that will happen. And that's your lesson for today. Animated PowerPoint Math video at AOL.com for questions or course materials. Thank you very much.